Right then, good afternoon everybody, hope you're all well. I'm standing in for Martin Doyle today, being your host as Martin's completing his practical apprenticeship out there on the shop floor. So you've got me this afternoon. I haven't got the same powers as Martin Doyle, so could I ask that everybody that hasn't already that you mute yourselves please, just so we don't interrupt the presentation.
Very smart, Gareth.
Yeah, I thought I'd make an effort today. It'd been a few weeks, Gordon, so I thought I'd better give it a go, as you do. Right then, so if everybody's tuned in and switched on, the presentation today is on behalf of HK Technologies. We've got Mr. Scott Elsmere, the guru, delivering a presentation on OPS Ingersoll, high-speed milling, V5 and V9. So, Mr. Elsmere, over to you, Squire.
Right, you are. Okay. Let's find where we are. Let's share that. So, you see that all right, Gareth? Afternoon, everyone. So, I'm going to give you an introduction into OPS Ingersoll, and we'll get it underway. So, OPS Ingersoll are located in Germany, 1.5 hours from Frankfurt, 2 hours from Dusseldorf, producing around about 120 die sinking machines and 120 high-speed milling machines, along with numerous automation systems. Producing gantry portal-style die sinkers and portal-style high-speed milling machines, true high-speed cutting. Today we're going to focus on the high-speed cutting, and we're going to be looking at the V5 and the V9 machines. High-speed cutting, true high-speed cutting, is often misinterpreted as fine finishing, small details, such as the applications that you see from one of our customers that specialize in flow regulators for plumbing, shower heads, etc. This particular application is a 60 Rockwell hardened pin. The roughing cutter on this was 2.5mm diameter, and the finishing cutter 0.4mm diameter, using our HSK E40 Fisher spindle. The machining time 1.5 hours. The customer was actually using other technology with just high-speed spindles from a leading brand, and subsequently was breaking lots of cutters and spending lots of time to actually produce the machine or to produce the part, due to the fact that you didn't have a true high-speed mill. In high-speed milling, we can also rough out. This is also a misconception. So here we have a block 150 by 100, 60mm high, that's been machined completely from solid and finished in under 5 hours. But on the same machine, we can machine the electrodes that you see in under 2 hours. So here we have an example of rough machining with a hardened block, and you can see we are removing significant amounts of material during the roughing application. Notice the blue chips moving into the swarf area. This is true high-speed cutting to remove the heat into the chip. And now we have a finishing application showing the versatility of the machine tool, using a very small cutter with very fine detail. The V5 machine has a very large cutting area, 550 by 400, for a very, very small footprint. HSK E40 and HSK E50 spindles, and 32 and 80 position tool changes. What makes a high-speed milling machine so different from standard milling machines? A standard milling machine has a high mass in the head to absorb vibration. High-speed cutting machines have a very light head. In this case, we use a 7:1, so the light head at the top and a heavy mass at the bottom. So 1 ton on the head to 7 tons on the base. This allows the machine to give a very high stability, a high dynamic, which helps, along with things like the control, in corner control. And this corner control, slow down and acceleration, is what we call in the industry jerk. The guideways, wherever the machine moves, we have a constant moving mass due to the gantry style design. Guideways are always supported at 4 locations, and this never ever changes. This means that you have a dynamic that never changes in the machine tool, unlike in a C-frame type machine. The electronics situated at the back of the machine tool are of course susceptible to shop floor dust and also vibration that might come through the milling machine. When we deliver the machine tool, the electronics package that's on the back of the machine is separated on installation to leave a gap in between, so there is no influence from the machine tool and no heat transfer back into the machine tool body as well. The Heidenhain TNC 640 control. Heidenhain is a recognized international control system. The TNC 640 was first embraced by OPS Ingersoll. It took over 1 year for the Heidenhain to bring up the dynamics of the control in line with what you would expect with a true high-speed cutting machine tool. There are many options from Heidenhain, but most of this we take care of in the machine tool. But some options we like to put towards the customer, for example, the 3D tuning cycle, depending on the accuracy of his process that we get the best result. Kinematic operation that sets up the 4th and 5th axis around the machine tool, and dynamic collision monitoring to protect the operator during machining so that he can't, for example, drive the spindle into the 4th, 5th axis. The cycle 332 is one of these cycles. The cycle 332 allows in the post-processor for the operator to ascertain what kind of accuracy he's actually looking to achieve and get the best dynamic from the machine tool, which also has an impact then on machine cycle time and also cutter tool life. Temperature is a very large influence into high-speed cutting, and spindles generate heat. We have over 10 temperature sensors around the machine tool, and we always try to get the heat out of the machine tool. Here, what we do on the spindle, where the spindle generates heat, we have 2 cooling flanges that are centrally lubricated with cooling to keep the heat away from the main structure of the machine tool. We're also monitoring any growth in the spindle during the cutting process. Other machine precision packages that we put together, for example, cross-grid laser. This is one of the standard features with the machine. But Precision Package 3 introduces the kinematics cycle that is quite often involved in 5-axis machining, but also especially developed with Heidenhain cycle 320. We provide a pallet with a workpiece and a probe, and following the kinematics, the operator can simply cut a small reference part on the sample piece with a known cutter size, and we can cross-compare that with the actual result, meaning the operator can, in that moment, at that time, tune the machine further. For very high accuracy and very high dynamic 4th, 5th axis applications, sometimes we need to get more out of the machine tool. So once the machine has arrived and become thermally stable, we can do laser tracing across the machine to take out any roll or yoke and vertical straightness. And we also do a cross comparison using a sample that has been certified, and we compare this with the customer's CMM. Often we find that the customer's CMM is also not up to spec. Taking it one step further, we can do a cross-torque compensation and heat thermal stabilization. This takes out any residual heat left in the machine tool and any stress movement in high dynamic. Here you can see the laser trace application in one position on the 4th, 5th axis. Of course, to cut, we need spindles. So in the V5, we start with a HSK E40 spindle, 42,000 RPM, which allows us to use cutters down to 0.2 millimeters diameter. Typically for fine finishing, some rough work, graphite, copper electrodes, but we do go up to a 36,000 HSK E50 step-tech spindle, which has a little bit more torque and power, allowing us to use down to 0.4 millimeter cutters but also going up to cutter heads of 20 millimeter and even doing some drilling operations up to 8 millimeter diameter. The tool changer to feed the spindle is a 32 position tool changer. We have one option for 80 position tool changer, also with a quick changeover. Both of the tool changers are sealed for clean room environment. One of the items that starts to make the machine tool from OPS very, very significantly different to other machine tools in the class is the 4/5 axis. Other machine tools in this class normally have a maximum loading of around about 60 to 150 kg. And also the diameter that they can typically hold on to is maybe 200, 250 millimeter diameter. Here on our standard gear axis, we have a maximum load of 250 kg, 400 millimeter diameter with a swing of -120 and +60. That's a turning speed of 20 RPMs. This is typically used for 3+2 type applications. 3+2 means that you are able to gain access to parts that you wouldn't necessarily be able to gain access to in the standard configuration without actually having to turn the part around. This can be steel parts or potentially something like a graphite electrode where you need a very small cutter to get in to finish fine small details. This is what we call 3+2. We also have a direct drive axis with a torque motor. This has a slightly lower loading capacity of 200 kg, but has a speed revolution of 100 on the C-axis. The table surface is 430, and again, the workpiece swing size is 400 millimeter diameter. Here you will see the torque axis in action. So it enables what we call simultaneous machining, but also items such as mill turn, where we have to move the axis very fast, reduces cutter tool, increases cutter tool life and reduces time cycle. Because of the position of where the 4th and 5th axis is slung, it again gives us a massive advantage over the competition in this area. So here you can see from the spindle flange in this particular configuration to the top of the workpiece pallet is 470 millimeters. Many of the competitors look at distances of around about 300, 350 millimeter to the top of the 4/5 axis. In the case we need to cut bigger parts, we pull back the top of the machine and open the doors, and we can bring in a 3-axis table, allowing for much heavier parts and larger parts to be machined. Infrared touch probe, of course, we use this for checking workpieces and carrying out using the Heidenhain control some basic inspections. But this can also be linked to systems such as Delcam Power Inspect, which give a full report of any work that's taken place or been machined overnight. The LCD Digilog laser, whilst giving us tool diameter control, tool length control, and breakage detection like most other lasers, this particular laser does away with the need for cleaning the tool. It can see through coolant, dust, etc., and also will trace the radius of the tool so that when we're using 3+2 or 5-axis simultaneous applications, we have an average position on the radius of where we should be cutting, giving higher accuracy. Also on the machine, we can cut aluminium in high volume, non-ferrous materials dry. This could be also electrodes, copper electrodes, but we use the same process for steel milling as well to give better tool life and also higher surface finish. Notice how the aluminium is not clogged into the tool during this process. This is done by the use of a technology by Rother called ATS Aerosol Master. This is not to be confused with MMS or oil mist. This is a very fine alcohol solution. A 5-liter canister on the back of the machine tool delivers 0.025 liters per minute. It can be, we have 2 configurations. It can be a 3-stage programmable or 30 stage programmable settings. It is delivered through the spindle, typically either through the tool or through some special tooling to give accurate alignment and positioning of where the aerosol mist should come into contact with the cutting tool. The idea is to prevent heat, not cure the heat. This could also be used in drilling applications. Here we have a HSK E50 spindle, and we are putting the ATS aerosol through the drilling directly to the front face where we are cutting, showing that we can do far more with a high-speed milling machine than is commonly thought as standard. Extraction, of course we need some extraction. The Keller unit not only will handle oil mist and aerosol, but will also handle graphite dust. This is very important in mold making. So this is a high volume graphite application, creating lots of dust. The machine is completely sealed for dusty applications. Even any dust that is settled on the side, at the end of the operation, the fourth and fifth axis will move, and we will collect a tool with no tools in it and use the air to blow down the machine tool. Also, we can use an extraction Hoover suction for cleaning down should we need to. The bigger brother, the V9, works on the same principles. We have a travel of 800 by 600 by 500, but here we start to offer more spindle choice. So we come from the E40, HSK E40 at 42,000 spindle through to the HSK A63, also not shown as 18,000 and 12,000 RPM. Again, we maintain the same kind of design and same kind of light head, but the big difference in the V9 for bigger parts is the double gantry system, drive system you see in the X-axis and the Y-axis. This means that we get no deflection in the drive, and in the X-axis, you can imagine any cutting forces on the cutting face are pushed equally, and equal distribution of energy is placed at the top and the center point of the axis. These are independently driven. Again, maintaining the light head of the machine, the tool changer is also positioned centrally on the V9. Here we have 88 down to 48 positions depending on the spindle choice. On the V9, we start with a gear and direct drive axis with 250 kg, but now with a swing of 600 diameter with the maximum table load. Ready to take the standard Aroa MTS pallets 498 by 498, and this is also possible by automation. The double torque axis gives us far more rigidity and strength, and also comes standard with a Heidenhain option LAC. This is where a part is loaded to the machine, the fourth and fifth axis moves, assesses the weight load, and then adjusts the torque parameters accordingly. This is also available on the V5 machine. At the end of the day, of course, we like to shut down the machine tool, but we will also need, with a high-speed mill, to go through a warm-up cycle. So the warm-up cycle with the Ecotech function automatically takes place before the engineer or operator comes into work the following day. However, we have 8,700 hours in a working year, and it's important that we get the maximum amount of those hours. All OPS Ingersoll machines have one thing in common. They can be left and right-hand configured and can be automated from the left or right-hand side. So here you see the V5, and here you see the V9 with a similar concept. OPS Ingersoll offer a multitude of automation systems, and from a high-speed cutting point of view, this starts with the multi-change easy. This is a very easy and cost-efficient way to start automating your process. The multi-change easy can be configured with 5 workpiece pallets. Here you see a UPC type pallet, which is 310 by 310. It cannot be mixed with smaller pallets, but this enables the operator to be place coded through the control, calling in work pieces, or should he need to cut smaller parts, perhaps they will cut steel parts during the day, and then at night fit an adapter pallet over the main pallet and call in the tool changer with a 40 position ITS 75, ITS 50 type holders, or 20 position ITS 115, 148 start. However, even with the 75 position, if the operator misses every other position, he can put in larger workpieces. This means we now cut small inserts, small electrodes overnight, and do our main steel components during the day. This unit is 45,000 euros and can be fitted at any time after the installation. The multi-changed light is the next step up. This is typically 8 work pieces, UPC, Dynafix type pallets, and 70 electrodes. It is a standard configuration. It is place coded or can be with chips and chip ident. We can do multiple configurations. For example, here we now see generally using the smaller ITS 50, ITS 75 type holders, but people's work will change, and we are currently now down in the west coast of the UK, changing one of these out as the customer's work has changed, and at any time we can reconfigure the interior of this and reteach the robot. Here you see a left hand and right hand configuration V5 with the multi-change easy and the multi-change light. The transfer weight is 100 kg, and in this example we have the larger 400mm style pallets, and of course we have to do away with some of the pallet space inside the robot's position. You can see here the transfer automatically for the adapter pallet, and then we will call in a small ITS 50 electrode holder, take it away, and then we will look to change the gripper to the ITS 115. So you can see how the multi-change light can give maximum flexibility. All the multi-change systems can feed two machines, hence the left-hand, right-hand configuration. So these two machines can be fed by one operator or could be independent. On the left-hand side could be a spark eroding machine, on the right-hand side could be a milling machine. The two operators could share the same automation system, or one operator can use one automation system feeding two machines. The electrode magazine in the top left-hand corner can also be updated with tools. So in the event a customer has taken a V5 with a 32 position tool changer and needs more tools, we can turn the back of the electrode changer into a tool carousel. In the case of the V9, and if they want to stay with a multi-change easy, we can add a robotic tool changer to increase the 88 positions to a total positions of 211. Multi-change flex enables us to feed 3 machines, again working with the OIPM, OPS Ingersoll's part management system with chips. All of these solutions are coming from one source. This is an installation of the multi-change flex, feeding the gantry 1200 machine and OPS Ingersoll V5. OPS Ingersoll often are involved in linear systems. Here you have a linear system with 3 spark eroders, 1 high-speed mill, washing machine, and also coordinate measuring machine. We are happy to work with partners such as Aroa and System 3R in such projects. So OPS Ingersoll have the capability for single machines, but also to take complete workflow. And when we speak about automation, most people will think of automation as production parts. Each workpiece pallet should be considered as an individual machine or individual item. And the automated process is literally automating everything you would normally do in a typical day. So OPS Ingersoll offer more than high-speed cutting machines. I like to think of it more as high technology, high dynamic, and high versatility. Whether the company is looking to invest in automation, they're looking for large workpieces, tool changing solutions, machining of graphite, to have flexibility to change workpiece sizes throughout the day or throughout the night, to carry out 4th and 5th applications or 3+2 applications, to machine non-ferrous materials without the need for coolant, to have accurate laser measurement of their tools, to carry out below 5 micron high surface finish in cases such as optics, to machine from solid hardened steel and create high quality molds and components, or to do something a little bit crazy with a large block of aluminium to kill the time while we're all sitting at home and program something that might take just a little bit longer to cut. So this is OPS Ingersoll, fly with the eagle.
Thank you very much, Scott. Absolutely cracking presentation there. I think everybody's just had a 25-minute PhD in into high-speed milling. So again, thank you very much for that. Hopefully that's wet everybody's whistle in terms of, especially the milling guys and girls out there. If everybody could just unmute yourselves and give Mr. Elsmere a clap for his presentation, please. Thank you. Okay, if you could mute yourselves again then, please. Okay then, so over to the questions, usual format. If you could just put your name in the chat box, just if anybody's got any questions about the technology that you've just seen there, we can kick off. Okay, Mr. Mark Colville, if you could unmute yourself, please, and ask away.
Scott, you mentioned about different materials that you can mill on the machine. Sort of, you mentioned carbide, you mentioned aluminium, etc. What changes do you need to make internally to the machine to switch between the different materials?
Yeah, so switching from graphite, aluminium, copper, steel, absolutely none. There's a usual sort of maintenance, brushing down, emptying the swarf tray at the bottom, for example. But other than that, there is no need to do anything. We have customers that are really, cutting steel parts and then switching over to graphite at night, next morning, literally come in, switch over the pallet system and go again.
Okay, thank you very much. Next up, we've got Jamie Fletchmore. You want to fire away?
Hey, Scott.
All right, mate.
Good. Just on the automation side there, is that Ingersoll's own automation system? Or
Yes,
is
it
it?
is. Yeah,
So,
yeah. So the multi-change easy and the multi-change light performance is their own system. They did buy a patent from a well-known supplier many years ago, but they then, let me say, adapted it, changed it, improved it for their own needs.
So is it something that we could adapt for our own milling machines?
No, I don't think so. I can ask the question, but I don't think so.
Yeah, maybe. Say we work with other systems, but if we've got something within the product range which is our own, if you like, then
yeah, we can ask the question, mate.
option,
Definitely ask the question.
Great one, Jamie. Thank you. Okay, next on the floor, we've got Mr. Steve Brown.
Hi, mate. Well done. In terms of, we've obviously taken an order, or you guys, or yourself has taken an order from what machines were they that you took an order for from within the range, and what's the application?
Okay, so we've so the application is in this case is actually all they're doing is machining graphite the complete time, and they're using pretty much the full stroke of the machine to do that on the 4/5 axis on a V5, the smaller machine, and it's literally cutting graphite all day, every day.
Right. Okay. So what would what's the part used for? What does it go into? Anything, or is it just to test?
So they're making an electrode, basically making an electrode. The electrode, I've got to be careful what I say here. The electrode is, let me say roughly so large. And on the electrode, there are many small electrodes, and it goes into a very large plate, small round medical parts.
Right. Okay. Very good. Cheers, mate.
Just on the back of our conversation earlier, Scott, about the 3 companies you identified, I know we can't mention their names on this platform, but do you want to discuss how they've embraced the technology, the applications it's used for?
Yeah, okay. So one I can mention, which is Go Tools. I'm trying to think now. It was, I don't know, 6 years ago, came to the Mac show looking for a very small spark eroder. But they had a bit of a vision, and some of the, let's say, our competitors just really opened the brochure, you know, a small machine, etc. And I did the same. But then I bought some sample parts at the table, asked them what their vision was for the future. They started off with a gantry 400 spark eroder. Very, very quickly realized they needed the high-speed milling machine. Then they realized they needed the automation on the side. Then they realized they had more electrodes coming out and more steel parts than they could handle. So then they bought a gantry 800, and it just really spiraled from there. Really, it's having that vision to get to that automation. The other one with the small flow regulators, they had a machine tool from a leading manufacturer that was fitted with a high-speed spin tool, graphite extraction, all the usual things, but a very expensive machine as well, I will add. And just couldn't get the results. So they ended up milling electrode spark eroding, which was taking time. And what they have to do, these flow regulators, depending on how the polymers shrink in the molding process, really the sidewalls need to be changed depending on the grade of the polymer they're getting in, really by sort of 5-10 microns, something like that. Because otherwise in flow regulators, you get whistle if the geometry is not quite correct. So being able to mill an insert, test it, get the flow rate, make sure it doesn't make any noise, or make some adjustments very, very quickly was very important to them. And the time down on that just, it sold the machine.
Okay, Scott, thank you very much, sir. Thank you. We've just had another one pop up. Mr. Dean Barnes.
Hi, Scott.
Oh, mate.
The OPS machines, are they dry machining only, or do they use coolant?
Yeah, okay. So there's only so much I can fit in. So we do a coolant package. One thing with the ATS aerosol is if you are, what I would say is if you're cutting aluminium and you're cutting more than say 40-50% aluminium, then we should look at a wet machine. Definitely look at a wet machine. The ATS aerosol, you know, for the tool maker and the mold and die industry, cutting copper, graphite, hardened tool steel, doing prototype molds, or some flexibility with some production work in aluminium. It does work, is possible. But if you're looking at a machine to solely cut, for example, aluminium non-stop, then we would look at a wet configuration machine.
Okay, cheers.
Very much. Next on the floor, we've got Mr. Derek O'Connor.
Hey, Scott. Well done, mate. Very good. Thank you very much for that. I see someone else has come in behind me more or less with the same question, but listen, I was asking myself, what are the main competitors for the OPS machines, and price-wise, how do they compare if given choice?
Okay, so the main competitor definitely is rotors. This is where the machine is aimed, but as I alluded to, if you take the RXP 500, for example, you need to get to the RXP 600 in order to get the same kind of stroke underneath the quill, and even then they don't still have the same amount of swing in the axis. So the figures I was pulling out about the competitors, that was Roder's, what I was comparing. Kern sits a little bit above. Those guys can split microns. But then you've got one or two machines, perhaps in the Makino range, one in the George Fisher range. That's it.
They're all more or less competitively priced, are they?
Yeah, more. Yeah. But basically, yeah. Very, very similar pricing. You know, your Roder's RXP 500 will come out cheaper, but then when you explain, obviously, the differences and what you can do with a machine, then it's a lot more machine for the buck.
Okay, fair play, mate. Thanks very much for that.
Thank you, Derek. Thank you. Peter, has your question been answered, or?
I'll put another one to you, Scott, if that's okay.
Yeah.
Obviously, the key feature of these machines is the high-speed spindle, and the black art that's required for machining cycles when you're using really small diameters. What warranty is available on the spindle?
Okay, that's a good question.
Standard.
Yeah. So the spindle, historically, we're working with Fisher. Fisher, across the board, offer a 12-month warranty. Unfortunately, it's non-negotiable. They will offer a 24-month warranty at the price of 2 spindles. So it's really on the life of the spindle is really down on Fisher. So in the HSK A63 and HSK 50, we've now started working with a StepTech spindle. The StepTech spindle used to have what they called a drippy nose. It was leaking oil years ago. They've solved that problem. And the general consensus is it looks like a more stronger spindle, but not available in the HSK E40 at this time.
Okay.
Are those spindles the same spindles used by the competition?
Yes.
Okay.
Okay, that's great. Thank you.
Thank you
On
very
the
much.
spindles again, Scott. Sorry, Scott, just on the spindles. What's the hours on the spindles? So you've got 12 months warranty, but like Peter was saying there, when you're running small cutters, high RPM for long periods of times, is there kind of like a number of hours associated with the warranty?
Yes, there is, Jamie, and I can't remember what it is, to be honest. Yeah, you've caught me out.
No, sorry.
You pick that up outside of this then, if that's cool. Okay then, Scott, absolutely fantastic technical presentation. I'm sure everybody knows everything there is to know about OPS and the high-speed milling offering now. If everybody can unmute yourselves and give a round of applause to Mr. Scott Elsmere, please.
Scott.
Well,
Scott.
thank you all for tuning in. Tomorrow we've got at 4 o'clock Mr. Paul Reeves from ETG discovering the Bavius TR80. So we look forward to that and the applications and delivery that can produce. Stay safe, everybody. Have a good day, and we'll catch up again tomorrow.
Cheers.
Cheers.
Take care. Bye.
Take care. All the best to you.